So I had number 12. So for the change, it goes with g, which is f of x2 minus f of x1. So that goes with change because it's just the difference in the two values. And then for percent change, that goes with I, which is new value minus old value divided by old times 100%, and the 100% gives you the percent change. And then rate of change derivative, that goes with A, which is instantaneous rate of change. And that's because it also corresponds with C, and the slope of the tangent line is related to instantaneous rate of change. And then it also goes with F, which is just the f of x derivative, which corresponds to that part. And then also D, which is the slope of the graph, and that's because the rate of change is just showing the rate and the slope of the line or graph that you're looking at. And then for average rate of change, that goes with B, which is slope of the secant line, and H, which is the f of x2 minus f of x1, so those are the rates of those values, and then divided by just the new value minus old. And then also J, which is delta f over delta x, and that's delta is like change in or difference in, so difference in f divided by difference in x. And lastly, the percent rate of change goes with E, which is f of x derivative divided by f of x times 100%, and again the 100% gives you the percent part of that. And then for part B, the answer ends up being A, so we can look at the birth would be like 0 weeks, and then 3 weeks would obviously be 3, so it's kind of going off of this formula up here. So it would be W3, so that's 3 weeks old, and then 0 weeks old, so the birth divided by 3, and then this is the kilograms per week on average. And then going down here, it's the same thing that's up there, so you would just look at from 12 weeks old to 26 weeks old, the giraffe's weight decreased, and it's decreased because this is less than 1, by 0.2836 kilograms per week on average.